Bienvenidos a nuestro último bloque de cosas que vamos a hacer en la plenaria antes de que se acabe y tengamos que esperar un año para encontrar un tema. Y bueno, antes de la charla quisiera, como tenemos un par de noticias, este probablemente para muchos de ustedes es un libro que ha permitido introducirse en ciencia de la LatinR y tener una versión en español siempre fue como un sueño para todos. Y eso ahora es posible y gracias a que un grupo de personas y usuarios de Latinoamérica se reunió y decidió realizar esta traducción de manera colaborativa y ese es nuestro desafío. Y no solo el desarrollo de la traducción, sino que también los paquetes que acompañan al libro fuesen traducidos para que todos pudiesen acceder a él. Y bueno, el paquete ya está listo, está publicado en Crack, de hecho el segundo release salió la semana pasada, y la traducción también está lista. Lo que significa que se van a acceder a para que lo mejoremos entre todos. Pero este es un trabajo en equipo. En la traducción participaron muchas personas de distintos países de Latinoamérica y hay varios que están hoy aquí de día. Así que quería pedirle que vinieran acá al escenario a Fernando, a Zulema, a Yanina, a Julia, a Elio, a Florencia, bueno, yo ya se fue, Patricia, Daniela, Pacha y Rox, que por favor vengan. Creo que como 11 aquí. Bueno, denle una... ¿Falta Pacha? ¿Dónde está Pacha? Bueno, si alguien lo ve afuera, dígale que no va a salir en la foto. Mientras llega, les pido que por favor les den una aplauso.
Hola, buenas tardes. Mi nombre es Zulema, soy de Hadley Wickham y le he pedido arriba solo 20 segundos para no interrumpir los tiempos. pero yo sé que hay muchas manos detrás de este proyecto de Art for Data Science en la traducción, pero en especial quería pedir un aplauso para arriba porque es una de las personas que ha estado detrás de todo esto de una manera descomunal. Por favor.
Pero además de ser una persona que se ha dedicado a desarrollar paquetes de R, también una persona que siempre ha estado muy preocupada de la diversidad de la comunidad de R, y eso se agradece profundamente. Y también ha estado apoyando muchos de estos proyectos que de una manera silenciosa ha permitido que desarrollen. Así que bueno, sin más, les pido que por favor den un aplauso a Hadley.
So I think this is, can everyone hear me okay? I think this is kind of a great transition to go from talking about the Spanish translation of R for data science to talk about the only languages I know how to translate, which are different computer languages. So what I want to talk about today is a little bit about how dplyr, through its different backends, can work with larger data sets. If my remote works. So to begin with, I want to talk a little bit about dplyr. So how many of you here have used dplyr before? Okay, awesome. Well, maybe I won't do too much explanation. But basically, I think dplyr is three things. So it's a collection of data manipulation verbs like filter and arrange and mutate and select and left join. It's also a tool that allows you to connect those little pieces together to solve complex problems. That's the pipe. And then finally, it's also a tool to program. By and large, dplyr is optimized for interactive use, for you iteratively exploring data sets and figuring out what's going on. But it also provides some tools to program with them, i.e. tidy evaluation. And so I think the most important verbs in dplyr, and I'm really mystified as to why my remote isn't working, are, first of all, filter, because often you want to take you've got a big data set and you want to narrow it down to a small piece that you're most interested in. Mutate, which allows you to add new variables that are functions of existing variables. Group by and summarize, which allow you to collapse large quantities of data to the key summaries that help you understand what's going on. Arrange, to change the order. Left join, which allows you to connect on other data sets. And I think the last one is one of the most important, but most people don't know about it, which is semi-join. How many of you have heard of semi-join before? Okay, that's awesome if you have not, and it is also awesome that if you haven't, because I'm going to give you a little demo of why I think it's so important. So today I'm going to be using a pretty standard data set you might have seen before. This is the NYC flights data set, which has a bunch of information about flights leaving out of New York. So this is filter, right? We want to say all of the destinations. The most interesting data is always data to do with you. And so these are the airports in Houston where I live. We can use that to filter those flights. We could create a new variable by the speed, for example, the speed, which allows there's the distance divided by the time. And then if we wanted to, we could plot that, which kind of shows something moderately interesting. Like as the flight gets longer, the average speed increases. And that's mostly because for very short flights, you're mostly taking off and then landing, and you have to do those at much lower speeds. We can group by and summarize. Here, I'm going to group by the destination, and I'm going to compute the average arrival delay, and I'm also going to count the number of observations in each group. And I think this is really important because if you just sort of naively arrange in descending order of delay, well, actually, let's find the airport that has the best delays, the shortest delays. You'll find, well, look at this airport. On average, the flights arrive 22 minutes early. Of course, there's only actually one flight to that airport. So this is what typically happens in analysis, right? You can't solve it with just a single one of these verbs. You've got to string multiple together. I'm going to group by the destination, summarize to compute the average delay, the number of flights, only look at flights that have at least one per day on average, and then arrange to look at the ones that might actually be the best. Now, of course, these airport codes, some of them mean something to me, but most of them do not. So it would be really useful to join on some additional data. So we could do a left join with another data set that we have, the airport data set, which has the airport name, the three-letter code, the name, and the location, and so on. So we can join that on to figure out exactly what these airports are, and maybe I want to just zoom in and look at the first few variables, so maybe just the destination, the delay, in, and name. Okay. And you can see, well, Honolulu Airport, that's a good place to fly to for multiple reasons. This one's kind of interesting, right? We've got this STT has a missing value here. So that's kind of interesting that we've got an airport that there's something different about it, right? On average, flights arrive early at this airport, and we don't know what airport that is. There's something missing in the data set. It's very, very, very common. Now we could actually, and that reminds me, we could do this. We could, if we wanted to figure out what are all the airports we have in the flight data set. How do we do this? Let's do count dest. And then I could say, well, tell me all of the airports in this data set that don't have a match in the airports data set. So I could use an anti-join for this. And here I'm going to join anti-join on the airports. On the left-hand side is the destination, and the right-hand side is the FAA code. And this is kind of interesting. So this is telling me that there are 4 airports that I've got data for in the flights table that I don't have data for in this airports table. This is an anti-join, really useful way to figure out why don't my 2 tables match. And then the last thing we might want to use is a semi-join. So here I have just taken all of the flights, counted the destinations, arranged them in descending order of how many flights there are, and then just looked at the top 20. So I've got the top 20 destinations in here. And now I might want to say, well, give me all of the flights to those destinations. And I can do that very simply by using a semi-join. So normally, like with a left join or a right join, they add new columns. A semi-join doesn't do that. It just filters the rows. And so it's a really useful way of saying, give me all of the records in this table that correspond to this table. So here I can use it just to filter. So I'm looking at the biggest airports when I again do the summary of delays. So the idea of dplyr is that you have these simple verbs. Each verb does one thing well, and then to solve a real data analysis problem, you string them together one after the next with a pipe. And the kind of idea here is, or my model, or certainly the way I do data analysis, is I do it wrong like 10 times before I do it right. And so the important thing is to be able to iterate quickly, to try out lots of different things so you can get to the right solution as quickly as possible. Now, as well as that, using dplyr interactively, at some point you're going to realize you've copied and pasted your dplyr code a bunch of times, and you might remember the rule of 3, which is whenever you've copied and pasted code 3 times, it's a really good idea to make a function. But if you take code like this and put it inside of a function, and now say, well, I want to be able to compute the delay grouped by any variable, if you run this code, you'll get an error saying that column VAR is unknown. And that's true, right? There's no column in the flights data set called VAR. We want to use some sort of indirection. We want to use not VAR, but the value that's stored inside VAR. We want to use origin. And this is basically the problem that tidy evaluation tries to solve. And I don't want to talk about tidy evaluation at great length here because it's fairly complicated, but we now have a pretty simple solution for this problem, and that is you embrace the variable, which is a pun on these are called braces, and it looks like you're hugging it. So you embrace the variable. And that means now dplyr knows not to use this variable literally, but to use what you've supplied to the argument of this function. So this idea is called tidy evaluation. If you ever have a problem writing a function using dplyr or other tidyverse code, looking up the details of tidy evaluation is a good place to start. But what I wanted to talk more about today is how does dplyr help you work when you've got larger data sets? And like, what does that even mean? What does big data mean? And I have two kind of very pragmatic definitions for big data. The first definition is that you spend more time waiting for the computation to happen than thinking about what computation you should do. So whenever you're waiting a bunch, I think that's a big data problem. And the other kind of definition that's useful is whenever it's just moving the data from one place to another is annoying or time-consuming. You can't just like put it in an email. You can't put it on GitHub. You can't put it on a USB drive. Like just moving the data from one place to another is a significant hassle. I think that's another good pragmatic definition of big data. And I think one of the key ideas when you're working with big data is that you don't want to bring all of that data to your computer because that's going to be slow and annoying. What you want to do instead is send the computation to where the data lives. And so what I want to talk about today is the way that dplyr kind of helps you kind of ease into this different model of computing where the data lives somewhere else and you send the instructions as to how to compute with it to it in a fairly natural way. So normally when you use dplyr, you're just working with data frames or tibbles. You use the kind of native dplyr backend, which is written in C++. Today I'm going to talk about data table and how you can use that, how you can write the data table code by having dplyr write data table code for you, and then how can you write SQL code by having dbplyr write SQL code for you. And then you can kind of keep the data table is really fantastic for large in-memory data sets that can fit in memory on your computer. Relational databases are good for data that doesn't fit in memory, that maybe fits on the hard drive of a single computer. I'm not going to talk about this today, but if you get even larger data sets, you might be using Spark, where you don't just have one computer that the data lives on, but you've got tens or hundreds or maybe thousands of computers, and you can use Spark to be able to work with that. So the basic idea of all of these backends is the same. You write dplyr code, and then these individual backends are going to do the translation for you. So how many of you have heard of data tables before? Okay. Data table is a really awesome package designed to make it incredibly fast to do data manipulation tasks. But personally, I find the syntax a little bit hard. It's very, very concise, which means you type very few characters, but you have to kind of think a lot when you're reading it. And so what my goal was with dplyr was to try and get what I think at least is the best of both worlds, to have the performance of data table with the syntax of dplyr. Or if you already know dplyr, how can you easily get the performance advantages of data table without having to learn an entirely new syntax? And the idea here is that you're going to continue to write dplyr code, and then dtplyr is going to write the data table code for you. It's going to translate your dplyr code into data table syntax. So let's make this a little more concrete with an example. Just going to restart R. And the first thing you have to do to use dtplier is to turn your data frame into what I call a lazy data table. I'll come back to what I mean by this in a little bit, but basically this is what we need to do to get started. And so now I can still use exactly the same code that I wrote before, and what dtplier is going to do is it's going to translate that into data table, the equivalent data table code for me. So we can do that for all the basic things. So if you do a mutate in data table, you use the slightly weird looking colon equals operator. And I'll talk a little bit later about what this copy is. But basically, if you've never used data table before, all you need to know is that, well, there's nothing you really need to know, because the goal of dtplier is it'll just translate the dplyr code you already know. So I can just run through all of those things I did before, and it will translate my dplyr code to data table and then run it. So what do I mean by this laziness? So if I have this lazy data table object and I assign it to an object, this is always going to happen basically instantaneously, because no computation has actually occurred. The idea of laziness is that, I mean, the idea of laziness in real life, you do as little work as possible until someone forces you to do the work, you're not going to do anything. So this is the idea here, that until, for example, you look at the data frame, that's going to have to do some computations to actually see what the results are. You can also just see what would happen, or what data table code will be generated by using this show query function. And I should have asked this earlier, but can everyone in the back see this code? Okay? Or make it a little bigger? Okay. Okay. Seems to be okay. So we can just say, tell me what you're going to do when you run this code. And then finally, you can actually force the computation by using a function like collect, which returns a tibble, or you can use as.dataframe if you want a data frame back, or as.datatable if you want a data table back. So this is a little bit different from dplyr, right? Normally when you run dplyr code, each time you run a filter or a summarize, that action kind of happens immediately. Whereas here, we have to kind of do something at the start. We've got to say this is a lazy data table, and we've got to do something at the end. We want to collect all the results. So that is a little bit more work, but the advantage is that now dtplier and the data table can look at the entire sequence of operations you've done, and it might be able to figure out how to operate on those, how to do that more efficiently. So a really good example of that, which well, I'll show you a couple of little examples of that. So one place where this arises is, so maybe you filter your data set and then you select some variables. Now, this is actually kind of an inefficient way to do things, right? Because when you filter, R has to go through and filter every single column in your data frame. And you go and immediately throw a bunch of those away. If you never look at them again, why did you bother doing that work to filter them? And so one thing that dtplier can do is kind of recognize that. And so when you run this code and look at the output, you'll see there is just one data table step here. So first we do the filtering, and then simultaneously we do the selection. And so running this code in data table is actually substantially more efficient than running it in dplyr, because dtplier gets more information. It can consider the complete sequence of operations you're doing, and it can notice like, oh, hey, you only actually need these 5 variables. I don't need to filter all of the other 20 or so variables. Another case where this comes up is when you're doing a left join. So for example, when you join on the airport data, and maybe you just want the name of the airport, like if you did this with dplyr, it's going to join on it joins all of the columns in flight to all of the columns in the airport. And then in the next line, it immediately throws away like 90% of the work it just did. But when we do this with dplyr, again, it gets translated into a single data table sequence. The joins in data table look like this. You have and I always forget around which way around it is, but you've got the table that you're joining to and the table that you're joining from, and then what variables do you want in the output, and then how do you want to join those two data tables together. And again, this is going to be much more efficient because data table doesn't have to like move a bunch of variables around that you later throw away. Now, the other big difference between dplyr and data table is that data tables are mutable. And what that means, let's just create a little data table. Just make a little variable. Let's call this dt1, we'll call this dt2. We'll just make that dt1. And actually, let's do this first with a data frame. So here I've created a data frame, and I've basically given that data frame kind of two names. I can call it df1 or df2, and if I look at them, unsurprisingly, they look identical. So what happens if I add a new variable to df1? What happens to df2? So if I look at df1, obviously it gets a new column called y. What happens if how many variables is df2 going to have? It's just going to have that column x. Because and normally in R, whenever you think you're modifying a variable, you're actually creating a copy of it and modifying that. And that's one of the things that I think it makes it much easier to reason about your R code, because you know things are never kind of going behind your back and changing an object that you have. But it's also something that makes R relatively slower because it has to make these copies all of the time. The data table, if we do write the similar thing in data table, and hopefully I can remember how you write this in data table, you use this special operator. Oops, I need to run this code first. It would help if I loaded data table first. So if we look at dt1, you see it has those columns x and y just as when I was working with the data frame, but when I look at dt2, it's also been modified. And so this is one of the features of data table that makes it incredibly fast, because it can modify objects in place. It doesn't have to make copies. This is something, however, I just sort of don't like this. It feels like someone can go behind my back and change my data frame. And it's certainly not compatible with the idea of dplyr, because dplyr, as I'll talk about shortly, also works with databases. And when you have dplyr code, if you have something that's in a database and you go dt and you mutate it, if this was in a database and this code went and modified code in your production database, you will have some extremely angry person in your organization coming to you wondering why you've changed the database. Now, actually, that's unlikely to happen because that person would never have let you change the database in the first place. You'll actually just get an error saying you're not allowed to modify this table. But I think this idea is it's really important to dplyr, that every time you think you're modifying a data frame, you're actually creating a modified copy, so things are not changing behind your back. So how do we kind of reconcile that? How do we combine this idea of dplyr that you want to have these immutable, these unchanging data frames with this idea of data table, which wants to be able to modify in place so that you have better performance? Well, and the way that we kind of reconcile that is that when we're generating data table code, we will dplyr will automatically copy the data frame if it looks like if you're doing any data table operation that would otherwise modify it in place. So it will create one copy for you. And it does this as kind of smartly as possible. So if you do two mutates, if you do one mutate and then do another mutate, it's not going to have to copy the data frame twice. it's only ever going to copy it. There are other cases where it kind of looks like you are modifying, like if you do a filter and then you add a variable, you're not actually modifying the original data table in place. So dtplayer knows that and knows because you've done a filter, you've kind of created like an implicit copy of the data frame because now you've had to filter the rows, so you've got like a different object now, and so it doesn't create a copy there. And then finally, if you really want to, if you really don't like this idea of immutability, you can opt out and you can create a data frame, a new copy. So this is kind of, I think, one of the challenges of, well, this is like one of the challenges of translation. Like when you're translating between two languages and like the words mean slightly different things. It's hard to have like a perfect one-to-one translation. And so this is sort of one of the places when we're translating between dplyr data table code, things get much more complicated because of this sort of semantic mismatch. Now, how does this end up working in terms of performance? So let's compare. And to do this comparison, I'm going to use a really cute, and I use cute in both a positive and a negative sense, a really cute way to create a function, which is if you start a Magritte pipeline with a dot, instead of an actual object, it's going to create a function. It kind of, instead of actually doing the stuff in the pipeline, it creates a like pipeline recipe that you can then apply to other data frames or other objects. So here, if I just print this out, you'll see this is a functional sequence. It groups, then summarizes, then filters, then arranges. And so I can use this with the benchmark function to kind of compare the performance of taking my lazy data table object, applying that sequence of operations to it, and then collecting the result to exactly the same thing, but directly with dplyr. And you can see in this case, it took, on average, about 9 milliseconds to do it with data table, and it took about 30 milliseconds to do it with dplyr. So there's substantial performance benefits to using data table. Now, of course, in this case, like it's like 3 times faster is one way to think about it. The other way to think about it is that it's 22 milliseconds faster. And so in this case, like, you know, you've just spent 15 minutes learning how to do this. You're going to have to save a lot of 22 milliseconds before this is useful. But when you're working with larger data sets, and this is a pretty small data set, this gets much, much more important. The other thing you might want to ask, well, what's the cost of doing this with dtplyr rather than learning data table and writing data table code directly? And so what this benchmark does is it compares just running that sequence of operations, which just does all the computation, which generates the query, that generates the data table code, with actually doing all of that and executing the data table code. So the difference in runtime between this and this is kind of like the overhead of we can use that to determine the overhead of the translation. And so in this case, it takes about 1 millisecond to generate the translation, and it takes about 10 milliseconds to actually do it. So this is a pretty high overhead, right? This is adding like 10% of the time of this is this additional overhead from dtplyr. But what's important is that that overhead is proportional to the size of your pipeline, not the size of your data set. So if we load in a larger data set, so I dug this up on my computer, but this is the complete, all of the flights in the US from 2013. So there's about 6 million observations here rather than 300,000. It's about 20 times bigger. If I redo that benchmark, first of all, I have to compute it to a data table, which I'll do a little bit faster. In this case, like now it's takes about 700 milliseconds for dplyr and 100 milliseconds for dtplyr. So this is starting to get into the point where you're going to notice a half-second difference. It's not, you're not going to be like, well, I'm going to go away and get a cup of coffee, but it starts to feel like the computer's a little laggy, right? Like it has to think for a little bit rather than being instantaneous. And that can, I think, disrupt kind of the flow of your analysis. So now you're starting to see the payoff. You're saving half a second every time. And if you look at the translation cost, well, the translation cost, because the size of the pipeline hasn't increased, is just the same. So it's still that 1 millisecond. And now it's like less than 1% of the total runtime is spent in translation. So I think for when you have enough data that using data table is going to pay off, the additional cost of using data table via dtplyr is going to be very, very small. Which is a very long-winded way of saying that I think like dtplyr actually makes sense, like it's actually useful. Okay, so I talked about kind of 3 things here, this sort of idea of laziness versus eagerness. Normally when you use dplyr, at each step in the pipeline, the data is immediately transformed. But when you use dtplyr or dbplyr, as I'll talk about shortly, it's lazy. It doesn't do any computation until you force it to by collecting the data. That's obviously a little bit painful because you've got to remember this additional step at the end, but the advantage is that there's much more information available to figure out how to do that computation more efficiently. So we talked a little bit about how data tables are mutable. You can change them in place. dplyr basically never modifies things in place, so we need to figure out how to combine that, kind of figure out how to overcome that semantic difference in our translation. And then finally, a little bit about the performance. It costs maybe a few milliseconds to do the translation from dplyr into data table. That is proportional to the number of steps in your pipeline, not the size of your data set. So generally, I think dtplyr is going to make, if you've got something in dplyr that's painfully slow, you should be able to try it out with a couple of lines of code and potentially get a big performance improvement. Now the other thing that's much harder to kind of quantify is maybe like I have had to write code that takes your dplyr code and translates it to data table code. And maybe I haven't done a very good job of that. Maybe I've generated like suboptimal translations that might not be as fast as you could, you might be able to write faster data table functions. Now I've tried to overcome that by like talking to people who are really good at data table as much as possible. And fortunately, it seems like the design of dtplyr, if I do discover there's a better translation, it's pretty easy to implement that. Okay. So that was dtplyr, which allows you to translate your dplyr code to data table code, which generally helps you work with large in-memory data sets much, much more quickly. Next, I want to talk about dbplyr, which you might want to use if your database if your data lives in a database somewhere. And so generally in R, when you want to get data either into or out of a database, there's at least 2 packages in play. Typically, you're going to use the DBI package. DBI stands for, I think it stands for Database Interface. It's basically a standard. It gives you a standard set of functions for connecting to any database. And then you couple that with a package specific to the database that you are connecting to. So these are the 3 popular databases. SQLite, you use the R SQLite package for that. If you want to connect to R Postgres, you use the R PostgreSQL package. If you want to connect to Oracle, you use the R Oracle package. But most of the time, you don't need to care about the details of these packages. These just take care of the details of connecting to the database. You just use DBI functions. But when you are working with these packages, you always have to write SQL. You have to understand what SQL is. SQL, the language of, it's short for structured query language, but it's basically the language that databases speak. And so when you're working with databases, you might write code like this. You load the DBI package. You connect to a database. Here I am not connecting to a realistic database. I'm going to connect to an in-memory database and copy some data in it. Normally, you are connecting to a database that someone in your company or organization has provided, and then you run some code against that database connection with some SQL. How many of you have seen SQL code like this before? Okay. If you haven't ever used SQL before and you want to get a job as a data scientist, I highly, highly, highly recommend learning about it. And kind of fortunately, if you know dplyr, you've got kind of a heads up because there's often a pretty straightforward translation from this SQL, select year, month, and day. Well, select is basically the same as select in dplyr. Select those variables from the flights data frame where, oops, that's not dplyr code. It's not quite that simple. And then filter it to select this destination. So the basic operations in SQL are very, very similar to the basic operations in dplyr, and that's not a surprise because dplyr was very heavily influenced by SQL. One of the things that is kind of annoying about SQL is that you have to write these things in exactly this order every time. It always goes select from where. You can never change the order, even if it might make it easier to understand for your specific case. And so as you write more complicated code, so here select destination, I want to compute the average of the arrival delay as a new variable called arrival delay from the flights data set, group by destination. That's very similar to this dplyr code. But again, personally, I think this is a little easier to understand because the group by comes before the operation. Like when you read this SQL code and you see average, you kind of immediately have to think, well, this is average is an aggregate operation, so I'm going to expect somewhere later that there's going to be a group by. Where I think saying like up front, we're going to group by this variable and then do stuff to it, I think that's a little bit easier to understand. So by and large, I think like if you are familiar with dplyr in maybe a day, you can figure out the basics of SQL. I should say SQL is like an absolutely immense language. Like if you want to understand all of it, it's like, I don't know, there's probably like 10,000 pages of PDFs you'd have to read. But fortunately, the only SQL command, basically, that you need to know as a data scientist is the select command, because that's what gets data out of a database. And that's normally what you care about as a data scientist. You want to get the data out of the database and into R so you can do stuff with it. The people looking after your database, the database administrators, data engineers, they have to care much more about how do you actually do this all efficiently, how do you pull the data into the database quickly, and then how do you make the data scientist queries run as quickly as possible. But there are like a few kind of really annoying little differences. Like, for example, in R you use double equals, but in SQL you use single equals, and in R you can use double quotes or single quotes for strings, but in SQL you can only use single quotes. In SQL, well, it's not called mean, it's called AVG. You don't use the caret to do raise to square things, you use the power function. So if you're like writing some R code and writing some SQL code, I think it's really hard because you've like got to constantly like context switch, and there's all of these little differences that will trip you up. So I kind of thought, well, like, can we try and automate this translation? So can you just write R code, and can we figure out how to translate it into SQL for you? And that's basically the idea of dbplyr. So you write your regular dplyr code, you use dplyr in the back end, and that writes the SQL code for you. I still think you should learn SQL, but in a lot of cases, because you want to be able to like know what dbplyr is doing, but I think this can be like a really nice way to actually learn it, because you can write the dplyr code and then see what you get. So I'm actually going to create a database. I like to use SQLite because it allows you to create like a database and then throw it away like 15 minutes later, which is generally how I use databases because I'm doing them in a demo. Generally, you will, someone in your organization will have told you, we use a Postgres database at this URL and this port, these are your username and password. and that's how you would connect to it. Okay, so now I have, again, the flight data set. It behaves basically the same way as that flight data set, data frame I've been using the whole time, but this time it's actually stored in the SQLite database. And so I can again work through some of that code I ran before. So I could take the flights database, group it by destination, and then summarize it. And let's see what query that generates. So basically, select, rename, summarize, mutate, and transmute all correspond to select in SQL. And I think that gives me like mixed feelings, right? You've got 5 functions that all do the same thing as one function in SQL, but I think this is good because those functions differ in important ways, and having these different names kind of helps signal that you're doing different things in your code. But basically, select, mute, summarize gets converted to a select, group by gets converted to group by, and this is the SQL code that we generate. This is probably pretty close to the SQL code you would write by hand. The main difference is I've put these backticks around every variable and every table name, and that just means that just makes sure, like, if you have a data frame in R that has a variable called select, like that's totally fine in R, but when you translate that to SQL, SQL will complain because it expects select to be part of a query. This just makes sure that doesn't happen to us. So if you're familiar with SQL and you're reading this code, you can just like mentally subtract off those backticks. The other thing one of the things that I find, like when I write, I did a little project last Christmas, like when I have Christmas break, like the things I do for fun are like data analyses. And I thought it'd be fun. Well, like, I'm going to do this in SQL. I was working with a big data set on Amazon's LatinR. I was like, wouldn't it be really fun to just like practice my SQL skills? I did that for like, 2 hours before I became so frustrated with SQL. And this is like my main frustration. So here I've done a mutate where first of all, I divide the air time by 60 to convert it from minutes to hours, and then I convert the speed from distance to air time. So you can't do that in a single select statement in SQL. You've got to do what's called a subquery. So here, where I say from, normally I'd have the name of a database table or a data frame there. Here I have another select query. So this select query, first, this divides airtime by 60, and then this query can then use that airtime variable to compute speed. And so if you're working a lot with SQL, or at least when I'm working a lot with SQL, I find this really, really annoying. And so this is one of my favorite features of dbplyr, is that it automatically generates all of these subqueries for you. Now, sometimes it generates like way more subqueries than you would normally write by hand, but most of the time that's fine. So we can also, other translations, filter becomes where, arrange becomes order by, and head becomes limit. So here I have a sequence where I filter to find all the planes going to Houston. I select these variables, I arrange in decreasing order of distance, and then I look at the head, and then that generates this single SQL statement. So again, this is one of the advantages of the laziness, because dbplyr can look at the whole sequence of calls. It can generate like a kind of the most natural SQL. It doesn't have to do each operation. It doesn't have to turn each operation into a different query. So this laziness is really important for performance here. And then functions like left join in R become left join in SQL. And then when I look at code like this, this is not like SQL code you would probably write yourself, because it's like very, very explicit. It includes this possibly unneeded subquery here. It calls everything left-hand side and right-hand side. So this is something that's like technically correct SQL. Databases will understand it and work with it. It starts to get a little bit different to what you would probably write by hand. Now, so as well as those kind of big picture, like each dplyr verb gets translated to a different one of these SQL clauses, there's also, unlike data table, which is just R, we also have to translate all of the little bits of R code that you write inside the filter or inside the mutate. And so we can kind of see what's happening there using this translate SQL function. So one of the little minor frustrations of SQL versus R is when you write a number like 1 in R, R assumes that's a real number. But to make a real number in R and SQL, you've got to put a .0 after it. Whereas in R, if you want a one that's an integer, you've got to put a capital L after it, which is just the same as a 1 by itself in SQL. So there, again, there's all these like little frustrations, or this thing, like this. This is the type of problem, like log in R and in SQL have the arguments in the opposite order. Like this, if you switch the arguments around, it's still going to work. It's just going to give you the wrong number. And this is the type of bug, like this is hours of head scratching, because it's so hard to realize, oh, this function just has the same argument, but they're in a different order. There are a few other like useful R idioms, like computing the sum of x when y is greater than 0. This is a really useful little idiom in R that gets translated to something a bit more complicated in SQL using case when. And then the other thing that dbplyr takes care of you is dealing with all of the different variations across different database backends. So if you want to join two strings together, depending on the database you use, there's 4 different ways to do it. So most databases, let me just clear this. Most databases use this concat_ws. This is basically the same as paste in R, but SQLite, for example, uses 2 vertical bars. And again, like if you wrote that thinking that was OR because that's what you use in R, you're going to get some wonky SQL. Microsoft SQL Server uses plus, and then Access uses and or ampersand. So this is the other real pain point of SQL, like SQL engines. Different SQL databases are like 90% the same. That last 10% is going to trip you up like every single time. Now, the performance, like by and large, is going to be worse in a database than doing it directly in R. So this is just comparing doing this in SQLite, which admittedly is one of the slower databases around, and doing it directly in R. Generally, the performance benefit, you don't see the performance benefit when all of the data fits in memory. If all of the data fits in memory, you probably wouldn't be using a relational database in the first place. The biggest benefit is that you can compute with data, you can get extracts, the extracts of data that you need from data that is too big to fit in memory that you never could have loaded into R in the first place. So the benefit of using dbplyr is not so much performance, it's enabling you to do things that you could not otherwise do. So to kind of sum up, you might have a big data problem if you spend a lot of time waiting for stuff to happen, or it's just painful to move the data around. And if you do have a big data problem, the ways that dplyr tries to help you are by providing you with these backends. So you can take what you've learned about working with just regular sized data frames in R, and you can apply that to larger and larger data sets. First, by using dplyr to work with much larger in-memory data sets backed by the really awesome data table, and then you can move up to dbplyr, which allows you to work with any size data that's stored in a relational database using dbplyr. You still need to learn something about these tools. I think it's really dangerous to I mean, I guess it's the same as like you don't want to rely on Google Translate for like a really important communication with someone. You don't want to rely on completely automated translations. You want to be able to like check that do they still make sense? Are they doing exactly what I want? I think it's still valuable to learn how to use data tables. It's still valuable to learn how to write SQL, but dtplyr and dbplyr allow you to get started much, much more quickly. Thank you.
Tenemos tiempo para algunas preguntas. Si quieren, las pueden hacer en inglés o las hacen en español y las traducimos. Así que, Rodolfo.
What's the difference between the embrace operator and the prime operator in Python?
So the question is basically about this slide.
If you'd asked how to do this 6 months ago, you would have had to learn about bang bang and in quo. And bang bang and in quo, I think, provide a really beautiful and comprehensive theory for quasi-quotation, which I wanted to share with the world, but the world is not ready for the full details. So basically, the embracing is a shortcut for this, which allows you to solve like the 90% most common tidy evaluation problems without having to learn any complicated theory, even though it's awesome and beautiful, and you should.
Thank you for your talk, Hadley. It was lovely. It's a meta question. Why did you change your theme from dark in the tutorial to default this time?
So Lara, if you'd attended Mina's talk yesterday, basically, like, I think, well, firstly, I toggle between dark and light themes in my own life. I'm not like a fundamental dark user or light user. But I think for presenting on the big screen, I think just light themes are easier for most people to read. That's why I have like a light background on my slides.
Hello, Hadley. Thank you for the presentation. It was really nice. I have a question in regards if there is a limit. Because when you use the dplyr, what's happening, you make transformations, a lot of operations, and then it's translated to a SQL query.
Yes.
Is there a limit to the size of the query?
It is, and it's...
And if there is, what can you do about it?
So there is, but I think practically you don't need to care about it. And my evidence for this is this model DB package by Edgar Ruiz, who's also at our studio. And it basically allows you to take models you fit in R and score them in the database by generating SQL. And so like if you do a k-means, it generates like SQL like this. Or if you generate, I could have sworn there used to be a random forest example, which generated like megabytes of SQL. So practically, like, if you can generate hundreds of kilobytes of SQL, which is vastly more than you'll probably ever need. It's possible you might run into these limits, but I think the fact that you can take a random forest, turn it into SQL, which might be like 5,000, and most databases can just like deal with that just fine, surprisingly.
¿Más preguntas? Allá atrás. De adelante vamos a hacer la de Elio primero y luego vamos a ir para atrás.
dtplyr does all this lazy not lazy evaluation, but it's lazy data point that then collects and takes into account everything you did and translates to an efficient, more efficient translation. So can't regular dplyr do that with regular tables?
Yeah. So dplyr definitely could do that, and I wonder sometimes if that's like a mistake, that it wasn't designed in that way. I think the problem is, though, it just, I don't know, I think it ends up being like a little annoying when you're writing code like this and you'd always have to add like a collect on the end. Like if your dplyr chain is like 10 steps long and you add a collect, it's like 10% more. But if it's one line long and you've add a collect, it's like doubled. And so I think that friction like it's sort of annoying enough that I wouldn't want to do it by default, but certainly you could imagine like having a lazy df that worked in the same way as like data frames did. And I think if you're going to do that, the problem with that then, I think I certainly could write that, and then I would have to like read a bunch of like database papers about like how do you do query optimization, and then I have to like replicate like the last 40 years of development by thousands and thousands of people in databases. So like, why not just let the databases do that? I mean, you know, it's not completely unworthwhile. I just think it's like a really big job, and like in most cases, like the performance is not that bad for data frames. If it's too slow for you, you can just use data tables now, and then you can use the database. So in terms of like the amount of work it would take me to implement versus the payoff, it just doesn't seem like that useful at the moment.
Hey Hadley, I have a question more related to the titlers in general. I think the titlers is really optimized to work with tables and data frames, and now sometimes we have some packages that actually do not allow this kind of class. For example, Keras, if you want to work with manipulate arrays or manifests that are the things that Keras accept, you cannot use this nice syntax of imply. Do you have any plans to try to tackle those kind of data objects, or do you have any tips to how to deal with these arrays that actually are not very intuitive and there's no, let's say, a nice syntax to work with them?
So I think mostly my answer is that like, me and my team are like focused like exclusively on data frames because that is like mostly what people need. However, Davis, who's on my team, made this array package, like array, pronounced like array, R-R-A-Y, which kind of tries to think like how can you work consistently with arrays as much as possible, bringing ideas from like Julia and NumPy in terms of like broadcasting, which makes life easier. And then under the hood, it's implemented with Extensor, which is a C++ library for very efficient operations. So this is like one little, I mean, sort of Davis has put his like toe in the water. This is not like a major, this is not something we're spending a huge amount of time on, but I think this is like one interesting avenue to consider. It also has a really awesome logo, but I don't know why it's on the website. I think I've already filed an issue about this, but it has a really awesome logo, and I'm pretty sure Davis has tweeted about it, but hopefully he'll, well, now we'll just watch this issue and see when he fixes it.
I think that you just shown some data sources like reaching different data sources. Is there any plan to get streaming back?
Not. So streaming data is hard because it keeps changing, obviously, and that makes it like a hard it makes it hard to fit into the model of like Tibbles, which as you talked about, like immutable and unchanging. You know, one way to do it is to work through something like the promises package, oops, let me change that. Which Joe Ching developed to work with China. Apart from that, I don't really know how they kind of like shoehorn that sort of data that's constantly changing into the model that R has, except through some kind of more complicated model like promises. Yeah, not for me. Maybe one day.
Lo siento, se acaba el LatinR 2019. Muchas gracias a todos por venir, por participar. Y bueno, dar las gracias al comité científico, ya los nombramos a todos. Bueno, Carmen, que fue una de las encargadas, está ahí atrás. Y muchas gracias, Carmen, y a ti y a todos los que pudieron venir. Muchas gracias al grupo de voluntarias y voluntarios. No sé si notan, pero que la lista creció. Aquí hay gente que no estaba antes y ahora está, así que muchas gracias a Nicola, Soledad, Cristóbal, a Catalina, Tamara, Mirelis, Daniela, Daniel, Joshua, Beatriz, Daniela, Juan, Ignacio y Macarena, que se sumó en los últimos 15 minutos como voluntaria porque se quedó afuera cuidando las cosas de todos. Así que gracias también. Gracias al comité organizador, al comité local, a Carmen, a Gabriela, a Alexis, a Luis, a Yanina, a Aida, a Pau, a Florencia, a Pati, a Marcos, a Roxana, a Ignacio y a Daniela, al equipo de redes. En el fondo, todo lo que vieron en Twitter fue gracias a que Yanina, Florencia, Patricia, Daniela, Rox y Luis en la cámara estuvieron activamente trabajando, así que les pedimos un aplauso, por favor. Y a Emi también un aplauso porque es nuestro trabajo administrativo. Y bueno, la Universidad de Ibáñez, H2O, Microsoft, RStudio, el Consorcio, el CERN, el CAC, Ciencias Ambientales y el Sticker, que fueron los oficiales también de la conferencia. Y a ustedes, obviamente, por venir. Se acaba la LatinR 2019 y nos movemos LatinR 2020 a Montevideo el próximo año. Y en 2020 tenemos dos chefs que van a entrar aquí a la organización, así que les pido por favor a Yanina y a Florencia que vengan para que la hizo que LatinR 2018 tuviera un espacio dentro de SADI. Si no fuera por ella, nada de esto sería posible. Y Flora ha estado desde el principio siendo un eje clave de la organización, así que estamos muy felices que nos acompañen. Así que muchas gracias. Los equipos se renuevan y Laura nos va a seguir acompañándonos como chef, pero quiero que por favor le dé una gigante Laura es una persona central dentro de la comunidad, en todo lo que tiene que ver con las comunidades en Latinoamérica, así que en el fondo ella ayudó a que esto impulsara, y ahora que ve que ya están dando, va con nuevos proyectos para seguir ampliando la comunidad en la región. Así que muchas gracias, Laura, si esto no hubiese sido posible, así que te vamos a extrañar, pero sabemos que siempre va a estar participando. Bueno, ¿y qué hacer mientras tanto? Porque seguro que tenemos un año. Próximamente vamos a subir al sitio web el enlace a las presentaciones, a las fotos que se han estado sacando, y tenemos esa organización en GitHub que les hemos puesto todos los materiales hasta los del año anterior, y que van a estar también los de los próximos, o sea, los de este año próximamente, pero queremos descansar un poco. Y por mientras recuerden que R no solo es las grandes conferencias, sino que también son las comunidades locales, así que averigüen si hay grupos de usuarios de R en su ciudad, si hay grupos de RLX, y si no los hay, fúndenlos. Ahí tienen una tarea para el próximo año. Hay mucha información, vienen quiénes las personas asociadas a cada una de las comunidades, así que pueden contactarlas. Y en la cuenta de Twitter se hizo una lista con todas las personas que habían participado, que tienen cuenta en Twitter, entonces si quieren ver quiénes son las personas que vinieron, están ahí, así que pueden seguir el trazo de la gente. En Twitter también este es el hashtag de la comunidad español, pueden estar siguiendo las cosas. Y también ese es el del equipo que trabaja en la traducción, pero también que ahora tiene este proyecto que es Datos de Miércoles, que todos los miércoles publicamos un dataset en español. Y ustedes pueden participar en esa comunidad ahí. Y bueno, muchas gracias. No sé si alguna de las chicas que vienen entrando quiere decir algo. Ya que está a punto de ir.
Sí, los esperamos en Montevideo, se me va el avión, gustazo, nos vemos allá. Trabajen mucho, muchos trabajos queremos el año que viene, Vamos.
Solamente agradecer por arriba, que la verdad es un abrazo en este LatinR, y también, bueno, que podemos decir una hora, es un montón. Así que gracias y nos vemos el año que viene.
Soy muy mal improvisando. Muchísimas gracias. Me dejo en excelentes manos la organización y el liderazgo de LatinR. Es hermoso y voy a seguir. No me voy a perder de vista, efectivamente, es difícil de poner de vista. Así que gracias, porque además, comparando, yo no sé, no hemos tenido mucho tiempo de charlar, pero comparando el primero y el segundo, este año se nota. El año pasado las preguntas hicimos todas cheas, casi hubo pocas preguntas porque no nos conocíamos, porque había esa incomodidad, y este año ya se nota que ya hay la comunidad, que LatinR empieza a ser comunidad en sí misma, y entonces hay más preguntas y hay más intercambio, que para eso estamos acá, para intercambiar, no para que alguien se suba al podio y decate. Así que sin ustedes esto no funciona. Gracias por estar acá y por muchos LatinR.
En el streaming, así que Nati, prepárate, que se viene harto trabajo. Nos vemos en 2020.